Okay, this is another distance problem. It's a little bit different than the last one where you had a lot of unknown information. In this problem, we're told the Martin family took a canoe trip on the river. They traveled 10 miles upstream in 5 hours. After having a picnic, they returned downstream in 4 hours. Determine the speed of the current, the speed of the boat in still water. Okay, so we actually know the time it took to go upstream and the distance upstream. If we wanted to know their speed upstream, we could find that, but that's not what the problem is asking about. See, because the idea here is that as they're traveling on the river, the current is moving the boat along or holding the boat back, depending on whether they're going up or downstream. And also, they could make the boat move at a certain speed on its own. And then either they're fighting against the current or the current's helping them out. So, to set a problem like this up, first let's put in what we do know. The time was 5 hours for both of them. So here's the picture you want to kind of look at. When they're going upstream, the boat's going into the current. So the boat, they can make the boat go at a certain speed if they were out in a lake or something. But the current's going to be holding them back. They won't be able to go as fast upstream because of going into the current. So you actually have the relationship that the speed of the boat relative to the current is going to be B minus C. And likewise, when they're going downstream, the current's actually pushing you along. So even if they stopped moving at all, the boat would still be moving forward down the stream. So labeling here, up and down. Again, up took 5 hours, downstream took 4 hours. And then what we also know is we actually know the distance is 10 miles. Now, it doesn't really say the distance downstream was 10 miles, except we're told they returned. So, back to where they started, we would assume, and since the problem doesn't tell us anything else, we have to assume that it is, in fact, 10 miles downstream as well. So, we want to determine the speed of the current and the speed of the boat. Well, we now have expressions in terms of the boat and the current. Again, assuming the boat is in still water, unaffected by the current. So that speed that they can make it move at and the speed that the current is moving at. And what we're really looking at in both of these are average speeds, because the current on the river will change and have different speeds at different times. And their paddling speed will probably change as well, but we're looking at an average. So we can plug those amounts in. And now, unlike the other problem where you had to really work to find an equation, here we can just kind of say, well, distance equals rate times time in both of them. So multiplying the rate times the time in both, 5 times b minus c would have to be equal to 10. 4 times b plus c would have to be equal to 10. Okay, and then we proceed to simplify. And at this point, you may want to pause the video and try to solve your system. And then here, I would probably choose to solve this by elimination. So I'm going to eliminate the c's. I would accomplish that by multiplying the top equation by 4 to get a negative 20c, and the bottom equation by 5 to get a positive 20c. Okay, and then I just combine. I get 40b equals 90. Divide both sides by 40, and I get that the boat on its own can move at a rate of 2.25 miles per hour. Okay, that's part of what we wanted. How fast can the boat move at? But we also want to know the speed of the current. So I take one of my equations. I took the 4b plus 4c equals 10. Put in that 2.25. And then simplify. 4 times 2.25 is 9. I get 9 plus 4c equals 10. Subtract 9 from both sides, get 4c equals 1, so c is equal to 0.25. So the speed of the current is 1/4 mile per hour. The speed of the boat is 2 1/4 miles per hour. And you can kind of consider these with our two scenarios. Upstream 10 miles in 5 hours would be a speed of 2 miles per hour. 2.25 minus 0.25 would be 2 miles per hour. Downstream 10 miles in 4 hours would be 2.5 miles per hour. If you took the 2.25 plus 0.25, you get your 2.5 miles per hour. Okay, so a little different than the last one. This is kind of a special case type problem. Most of them are more similar to the example in the other problem. Until next time.